In the previous video, I interrupted the construction of a tiny table band saw because the saw blade broke too quickly, probably due to a wheel radius that was too small. I have received many sensible responses regarding possible causes, for which I would like to thank you very much. After some internet research, it became clear to me that the smallest wheels on bandsaws are about 100 mm in diameter, instead of the 80 mm I used. The often heard reaction that such a wheel should be at least 200 mm is belied by the facts. I cannot imagine that so many top brands would offer bandsaws with a blade that often breaks due to a wheel diameter that is too small. But I thought 100 mm was still a bit on the small side, so I opted for wheels with a 120 mm diameter in the new design. There was something else that struck me about the saw bands themselves. On the left, a saw blade from Makita, with each tooth individually set. On the right is the saw band I used earlier, which broke so easily. The teeth are not set, instead the blade is corrugated. These waves are applied by providing the blade with fairly coarse and deep dimples that are applied alternately. I noticed that every crack in the saw was on the left edge of such a dimple, and there was not a single crack to be found around a bulge or in between. The extra rigidity caused by such a hollow impression apparently ensures that the blade bends much less in that area, resulting in a stress riser at the leading edge. With only minimal design adjustments, I managed to fit the four wheels with 50% more diameter into a C-frame that is only 50 mm wider and 14 mm higher than the previous design. Fortunately, even with these larger wheels, I can still call it a tiny tabletop bandsaw. The complete construction of this larger C-frame is not shown. The construction is virtually the same as that of the previous model. If you haven't already, see the previous video. Here the construction of one of the four wheels. This drive wheel will later receive a rubber tire, so the diameter must be reduced by 8 mm. Here the rubber band is cut to size and glued to the drive wheel. The wheel is turned true in the lathe. The new C-frame is finished. After properly adjusting the axles, the saw band should continue to run quietly and stably in the center between the wheel rims, regardless of the speed. Here, I am going to test that. This brings me to where I was 3 weeks ago, but now with an improved model, and so far no sign of the saw band suffering from metal fatigue. There is still a lot to do. But first I have to solve a problem. For reasons unknown, the speed of this brushless motor with this driver is at 1500 RPM, twice as low as advertised. Does anyone know a possible cause and solution? I was able to purchase a small stepper motor with a programmable controller for a very modest amount of money. I want to use this for an automatic, continuously adjustable feed mechanism. Now that I'm at it, I want to do it well. Here I have placed some plates of aluminum and steel on the C-frame to give an impression of the final shape of the machine. Much more about that in the next video. Until then,